Hey there, we're going to start talking about Lambda functions today, and in combination with function pointers will allow us to create functions in the middle of our code. So in our first exercise, we're going to make a Lambda function. What it's going to do is calculate a fashion quotient, and this is basically going to be a random number from 1 to 100 plus the length of an outfit, which is in this case just a string. We'll use the Lambda function to calculate and display the fashion quotient for the user inputted output. So let's go into public, to videos. This will be 11 or 10b lambdas. And again, the code for this is going to be a little bit shorter than usual, so I'm probably just going to make, I think I might be able to even get away with notebooks. Let's try it out. Lambda function that calculates a fashion quotient for a given. I guess actually I don't want to use a notebook, mostly because I do want to show some stuff later with regards to how Lambda functions interact with the code. So I may actually, let's just stick with a CPP. Better safe than sorry. Okay, so here's my description. Okay, let's make ourselves int main. We'll get IOStream. Standard namespace, save myself some time. Okay, so I want to have a function, we'll call it fashquo. This is going to be a function pointer. I'll use auto just to save myself some typing time, but I need to make this a lambda function. So lambda functions are going to have a capture group, parameters, and the code. We'll talk about captures later when we're actually capturing stuff. Right now we're not. All it's going to take is a string outfit, and the code of this function is to get a, I guess we need a random number, so include ctime, initialize the random number generator, and so we are going to return random number modulo 100 plus 1 to get a number from 1 to 100 plus outfit.length. And so now I can say string outfit, user, give me an outfit, enter an outfit, get line into my outfit string, and then output the fashion quotient is fashquo my outfit. So if I've done this correctly, what it should do is prompt the user for an outfit, get that outfit, and then I can send it to this function that I've defined inside of main. Whenever I leave my main function to go elsewhere, this function is no longer available. But for the time that I'm here, I now have a temporary function, a lambda function, that will allow me to calculate the fashion quotient for my outfit. So let's compile and run. What did I miss? I missed a semicolon before outfit. Yes. So even though this is a lambda function, because I'm declaring a variable, I do need a semicolon here. Running. I have t-shirt and jeans. The fashion quotient is 42 because I randomly happened to have picked that. And then on another day, my t-shirt and jeans might be worth 25. But in any case, it's at the very minimum going to be the length of this string here, because if I write something really, really long, t-shirt, jeans, and socks, and some other stuff, and a lot of characters just to make sure this goes over the limit of 100, because otherwise we don't know if the quotient is owing to the randomness or to the length of the string. And here I got to 259 because it's mostly taking all these characters and then adding some random number to it. Okay, and there is our first lambda function. If you want to replace auto with something, you can. So this is going to clearly return a integer. So it is a pointer to an integer, a function that returns an integer and takes as a parameter a string. So this will also compile, at least it should. Oh, I messed up. I think actually because I don't think I can use a normal function pointer for this. I think I actually need to use function int string. I believe that should do it. Yes? No, okay. What did I mess up? Oh, I have to include functional. Include functional. There we go. And it will do the same thing. So if you wanted to know what the auto was, it is a function from the functional library that returns an integer given a string. But something important to note is that when we are using a Lambda function this way, we can't use the same format for function pointers that we had shown in the previous exercises. However, we can use this version of function pointers, which is from functional, that just says here is a type of function called fashquo. So I believe if you dig down, what happens when you use auto is it just substitutes in this thing for it. And there might be a way to set it up with a normal function pointer, but for this purpose, we'll stick to using the standard function. Okay, that's exercise 1. Let's go on to number 2. So exercise 2, we're going to use capturing. So let's make a duplicate of this. And let's see what we're being asked to do. Make a variable in your main function that is the current year. Remove the randomness from your Lambda function and instead add a bonus to the fashion quotient equal to the current year modulo 100 by capturing the year variable. So instead of randomness here, I'm actually going to say int current year equals, and you can probably figure out how to get the actual current year. I just know it's currently 2025 as of recording of this video, but there may be a way that you can write something that will actually get you the real year. Probably you can figure out some math to do that, but I'm going to save myself some time and just type this in. And now I want to put in the current year here. It's current year modulo 100 plus the outfit length. But there's a problem with doing this, and I will show you why, which is that if I were to compile example 2, it will say current year is not captured. And so it even indicates where this is going to happen. So in here, you can indicate which variables you want to take values from, such as current year, and now have access to 2025 for this code. So compile, now run, enter an outfit, shirt, and now I can see it's exactly 30 because shirt has 5 letters and the year is 2025. So 25 plus 5 gives me 30. It's a lot more predictable. But what we have shown here is an example of capturing. And now the important thing about this is that the current year that's part of my fashion quotient is always going to be 2025. It means that later if I decide current year is 2030, my shirt still has a fashion quotient of 30 because 2030 is not being used as the current year for fashion quotient, it's just the variable value after this has been declared. And so if I want to change that, I need to use a reference if I want to actually have the current year be updated over time. Now we can see it's 35. So there are different options, but casting by value or capturing by value is done when you simply put in the when you just put in the name of the variable you want to put here. Or you can also put in an equals sign. This will capture everything by value. Okay, simple exercise, so we can go straight into the next one. So number 3. Make a outfit class that stores name, year, and fashion quotient. Then write a program that leverages the C++ standard library's sort algorithm to organize a vector of outfits based on their fashion quotient ratings in descending order. Okay, so a little bit going on here. We're going to have to look up some stuff to do this, but that's okay. So, we're going to make a class called outfit. Don't need those. It's going to have a name, a year, and a fashion quotient. When I create a new outfit, given a name and a year, and I suppose we'll give it a fashion quotient as well. Yeah. FQ, assign to name, year, fashion quotient. And we'll put in a display here just so we can see everything. outfit, year, year, fashion quotient, fashion quotient. So now I can see what an outfit looks like after I've made it. So here I'm basically just using a simple structure for this. So let's make some, let's make a outfit here. So here we're getting the outfit name. And now I can construct an outfit. Say outfit O. Outfit, I guess. Outfit. What we call my outfit, just so I can pronounce it a little more easily. We're going to need a name, which is the outfit name. We're going to need a year, which is the current year. And we're going to need a fashion quotient, which we can do fashion quotient given the outfit name. We'll leave the year as 2025 for this. So now I've constructed an outfit. Let's make sure I can display it. And I want to make sure all this works before I move on. So example 3, enter an outfit, shirt. So shirt outfit, year is 2025. I forgot the closing parenthesis. The fashion quotient is 30. Year equals year. Okay, now what I need to do is make a vector of outfits. So I'm going to need a few. So how about we do this a couple of times. Let's make 3 outfits. And we'll make a vector of outfits. So vector, I think I need to include vector probably. We'll make a vector of outfit. Oh, sorry, capital O, outfits. And now in here, I can say outfits.pushback new outfit and the parameters. So this time I will ask for 3 outfits. I will get the name of each one. I will put 3 of them into this vector. And now what I want to do is I want to be able to sort this vector. So the method is called sort. Let's take a look at it. So std sort. So how does it work? A good example to look at how it works is a sample code. So here they have an array, a standard array instead of a vector. So it's 10 integers. And how does their sort work? The 2 parameters it has to take are an iterator pointing to the first and an iterator pointing to the end. This is so that we know which range we're actually going to be sorting. So let's try that out first before I do anything. So outfits.begin, outfits.end. Now I don't think this will compile, but let's take a look at the error message if I'm correct. Yeah, so it doesn't, and let's see why. No matching function for, oh right, this is a vector of pointers. There we go. Let's fix that first, and now we'll see what the, oh okay, so it seems to be okay, but I don't think it'll do what I want. So let's now try running it. So let's say I have shirt, hat, and tuxedo. Well, probably want to display them all. For outfit and outfits, outfit display, so I can see them all. Shirt, hat, tuxedo. So we have still shirt, hat, tuxedo. This did not sort them according to the fashion quotient because you can see they're all still in order. And the reason for that is that there is a third parameter that we can put in here. You can see here it's called compare comp. And basically what this is a place you can put a lambda function to compare how they are sorted. And we can actually see an example of this down in the documentation, where here there is a lambda function where they say, hey, compare two integers and return if a is bigger than b. Now, what we want to do is we also want to put a lambda function in. So our sort is also going to have a lambda function, captures, parentheses, braces. So what are we capturing here? Well, we're capturing two different pointers to outfits. So we can say outfit pointer A, outfit pointer B. And what do I do with this? I say, and so this is supposed to be a function that returns a Boolean. It should be true if they're in order and false otherwise. And we want to look at A, arrow fashion quotient. And I don't remember if I want to do less than or greater than, so I'm actually just going to experiment and we'll see what I get. So I think this should do it in increasing order, but let's find out. Oops, compile. Oh, what did I mess up? Oh, yes. Fashion quotient is private within this context, so I cannot access the fashion quotient given that it is a private variable. And of course, I can't just say that it's a friend function since I am not calling it inside of some other function or class. So what I'll actually have to do is write a getter. Int get fashion quotient, turn fashion quotient. Now I can call this method. Let's actually move all this down a bit so we can read things a little better. I think I will tab it over once though. Okay, so my lambda function from the start of the outfits to the end of the outfits takes each pair of outfits and compares is the one on the left smaller than the one on the right. Let's see what happens when I run this one. Shirt, hat, tuxedo. So now you can see it's in ascending order. So smallest to biggest, 28, then 30, then 31. I want it to do the other way around because it says I think descending order. So to do that, I just need to switch this sign to be greater than. Let's try it again. Hat, tuxedo, shirt. It shouldn't matter which order I type it in because it will always give me the largest fashion quotient first, then the next, then the next. And so the power of the lambda function here is that I can decide every time I'm sorting something, how do I want to sort them? Maybe sometimes I actually want to sort them by name, in which case I can just change fashion quotient to name instead. I'll need a getter function for it, obviously, but what I now have is the ability to decide how I want to sort any two objects of any class by just putting in a lambda function inside of the sort call. So that wraps up exercise 3. Let's move on to the last one. So final exercise. Make a vector of outfits, which we've actually done already. That's helpful. Use the standard template libraries for each with a lambda function to provide a personalized fashion statement for each outfit in the wardrobe based on its fashion quotient. So I'll duplicate this again. And we'll take a look at for each. For each. Yep, that's the one. So how does for each work? With for each, you, similarly to how we called sort, where we gave it an iterator to the beginning and an iterator to the end, can then give a lambda function. And what happens is the lambda function will take each element of my vector as a parameter and apply the function to it. So here I'm taking a reference to each integer in this vector and increasing them by 1. In our case, what we want to do is take each one of the outfits, figure out its fashion quotient, and then print out some message. So I don't want to display everything right away. And in fact, I don't really need to sort them either. That's not necessary. So we'll get rid of that. But now we have our vector of outfits. And so what I want to do is for each, and here again, the beginning to the end of the outfits vector, and then my lambda function. And this time, the parameter I'm taking is a outfit pointer. I guess we'll call it outfit shirt. And now for that outfit, what am I going to do? It's probably a nicer way I can space this out, but as long as it's somewhat readable. Okay, so for my outfit, what do I want to do? I want to figure out what its fashion quotient is. So if outfit arrow get fashion quotient is greater than or equal to 30, we'll say too long, get a simpler style, bruh. Otherwise, nice and snazzy, real sharp. And so what will happen is for each outfit in my outfits vector, I will call this Lambda function given that outfit and run the code inside of here. So let's try it. Shirt hat tuxedo. And we can see that shirt and tuxedo have a fashion quotient of 30, so they are too long, need a simpler style, but my hat is nice and snazzy, it's real sharp. And that's pretty much it. We didn't demonstrate too many uses of the capture here, but it can be very important. For instance, if I needed to have some other data involved in this function, you may need to include it in your capture here, whether by reference or by value. A shortcut that you can use sometimes, which can be helpful, is actually just to say pass everything by reference. This is okay, but it may be dangerous because it may be that you're bringing in a bunch of variables you don't need to actually have access to. So be very careful about that because it's not always necessary. Okay, that wraps up this video. Thanks for watching, and I'll see you in the next one.